Okay, let's start with our first lecture. For Algebra 1. All right, so we're going to cover 5 sections of Chapter 1 in this first lecture. And that's because I think that most of this material you have already seen before, if not all of it. If you start to get really bored in this lecture, that's okay, because it should all be review. So as we start to get further into the semester, we won't cover more than a section per lecture. Okay, so here's a little bit of background history for algebra. Maybe this is interesting to you and maybe you'd rather just skip it. But I think it's kind of interesting. So the word algebra comes from an Arabic term, algebra. Don't know how to pronounce it, but its translation is the reunion of broken parts. And it's a title of a book by a Persian mathematician. And so since this term means the reunion of broken parts, it originally referred to the surgical procedure of setting broken or dislocated bones. So I think that's pretty interesting. So the roots of algebra can be traced to the ancient Babylonians in the 500s BC. And the Babylonians are the ones who developed formulas to calculate solutions for problems typically solved today by using algebraic equations. And on the other hand, the Egyptians and the Greek and the Chinese mathematicians, they were solving equations with geometry. So sometimes the Persian mathematician and astronomer Al-Khwarizmi, that's my guess, he's sometimes referred to as the father of algebra, but there's also the Greek mathematician Diophantus, and he has traditionally been also known as the father of algebra. So anyway, maybe there are 2 fathers of algebra. Okay, that's it for our history. So now we're actually on to section 1, which is titled Operations with Numbers. So an operation in mathematics is something you do to numbers, like add them, subtract them, multiply them, or divide them. So we also have an expression. So they're vocabulary terms, but you're not going to be quizzed on them. We'll just use those words all the time. So hopefully you know what they mean. Okay, so an expression is a collection of numbers, operation signs, and symbols. And then one of the first things we'll talk about with evaluating expressions is to evaluate the inside parentheses first. So parentheses can be curved, or sometimes the outer parentheses will be brackets, which are squared off. So let's work 2 examples. They are each 2 expressions, but if you know notice they have the exact same numbers in both of the samples, but the parentheses are different. So you'll get to see that the answer works out to not be the same. So the first example 1, we have to work with the inside parentheses first. So we're going to have to do 36 divided by 3 first. 36 divided by 3 is 12. So I'm going to write out all my work. So now I've done the inner parentheses. So now I'm going to need to do 12 times 4, which is 48. So now I've done the outer parentheses, and I need to add 2 and get 50. Okay. So, and just remember, if you need to pause to take time to understand my work, you can always pause the lecture and then resume when you're ready. So, example 2, we have the inner parentheses around the 3 and times 4. So we'll have 36 divided by 3 times 4 is 12. So since I've evaluated those inner parentheses, I went ahead and took them out. In my next line, I don't need them there. So I'm going to do the next set of parentheses. 36 divided by 12 is 3. And then I'm going to add 2 and get 5. So my favorite thing to do when I finish a problem is to box the answer. So on my tests and examinations, sometimes I'll have a blank for the answer, but if I don't, I think the best practice is to box your answer, and that way I'll know what your final answer is. And it's a great way to clearly communicate that you finished the problem and you got an answer. All right, moving on. Section 1 is done. Algebra is going to be easy. All right, section 2 is on variables. And a variable is a letter that represents a number. So a lot of times when you think about algebra, you think, oh, okay, that means I need variables. I need letters to represent numbers. So we often use X, Y, or Z as our letter to stand for a number, but any letter can be used. We can even use Greek letters. And a lot of Greek letters are used in advanced math. We can use a dot. Little tiny dot, see that little tiny dot? We can use a dot to denote multiplication. It's a lot less confusing than using the X for multiplication because we often use X as a variable in algebra. So in example 1, we're going to substitute 4 for X and evaluate the expression. So when it says substitute 4 for X, it means I want you to take 4 and plug it in for X. So I'm going to rewrite the expression, and instead of X, I'm going to write a 4. And then I have the dot for multiplication in this problem. So I'm going to evaluate the parentheses first. 15 minus 4 is 11. And then I need to do 11 times 3 is 33. Of course, if we substitute another number in for X, most likely we'll get a different answer. So let's try that. We're going to substitute 9 in for X into the same expression. 15 minus 9 times 3. So we have to do 15 minus 9 first since it's in parentheses. And then we do 6 times 3 is 18. All right, we're moving on. This is section 3 on powers and exponents. This is one of the sections I want you to make sure you know your vocabulary. It's very important that you know which piece is called what. So we have X and then a tiny y at the top. So X is called the base and y is called the exponent. Okay, this textbook refers to X to the y is called a power, which I don't know that I've exactly seen it that way before, but I wanted you to understand that that's what the book called it. I don't know if I'm ever going to use power that way. The way that I use power is in this line. So we have a tiny x, that's our base, and we have 5, and that's our exponent in this case. So we would say x to the power of 5, or more likely you would hear x to the 5th power. Sometimes I'll just say x to the 5th. That's the same as x to the 5th power. That's how I use the term power, not by calling the whole thing a power. That's a little different, but it's in your book. So let's do our first example. Evaluate. And it says 5 to the third, or sometimes we would say 5 cubed. 5 to the third wants us to take 5 times 5 times 5. So when we're asked to take something to a power of something, we want to multiply it by itself the number of times that the exponent is. So we want to multiply 5 by itself 3 times. So 25 times 5 is 125. So on a test as of now, I don't want you to use calculators because I want you to be able to do a lot of calculations either by hand or in your head. I will expect you to do something like 25 times 5. So yes, that means you're going to have to multiply out 25 times 5, old school. So if you guys have any questions about how to do stuff like that, you definitely need to ask me because I'm not planning on going through all of that. But within reason. I'm not going to have you multiply numbers like you might have done in 5th or 6th grade that are super long or big decimals. All right, let's go into example 2. Write each of the following as a power. So 7 to the 4th power. So we would write 7 with a little 4 at the top. 13 squared. So squared means we raise a number to the 2nd power. And part C has 1, 2, 3, 4, 5, 6 x's. So if we wanted to write that as a power, we would write x to the 6th. All right, moving on. Section 4 of Chapter 1, I think, is the most important of this whole set on order of operations. It's really hard for students and adults to remember the order of operations. It's kind of a way to trick mom and dad. If you want to ask them a question that you think they won't know the answer to, it might be order of operations. So there's a memory device to help us remember the order of operations. And the way that we say this memory device is PEMDAS. That's how I've always pronounced it. And so we call PEMDAS a mnemonic device. So that is pronounced mnemonic. The first M is silent there. It helps us remember the order of operations. So the P stands for parentheses, the E stands for exponents, the M stands for multiplication, the D stands for division, the A for addition, and the S for subtraction. I believe it's called an acronym. PEMDAS is an acronym, but it's also a memory device to help us remember what order we should do our operations in. When I was in middle school, I definitely learned this other mnemonic device, please excuse my dear Aunt Sally. And if you look at the first letter of each word there, you still get PEMDAS. And I always like this one because my mother's name is Sally. And she's an aunt too. Please excuse my dear Aunt Sally. So what this means is that when we're looking at an expression and we want to evaluate it, we have to evaluate the parentheses first and then the exponents. the rest of it has a little more explanation there. So parentheses first, then the exponents, after exponents. So we have multiplication and division, but it's not exactly that you do all the multiplication first and then all of the division. In reality, you want to multiply and divide at the same time in order from left to right. So after you do all of the exponents and you evaluate them in your expression, then you want to multiply and divide in order from left to right. After multiplication and division, then you want to add and subtract in order from left to right. So you don't want to do all the addition first and then all subtraction. That's not how it works. You do them at the same time and you work from left to right with addition and subtraction. So I made this beautiful slide. I'm just hoping it'll inspire you to doodle PEMDAS just everywhere so that you can remember the order of operations. Probably on your tests and your quizzes for this chapter, for sure, I would write PEMDAS everywhere. Okay, maybe not everywhere, but definitely at the top of your paper to help you remember. Maybe you want to like write a heart, draw a heart around it. I'm just kidding. Okay, so hopefully you'll remember what it actually stands for. Parentheses, exponents, multiplication, division, addition, subtraction. Hopefully you already know it, right? That's best case scenario. Okay, so let's actually try to use PEMDAS. As you can see, I wrote my little reference up there in blue. And so let's start with example 1. So we're supposed to evaluate this expression, and I'm going to start with the parentheses first. All right, now I have an order of operations within my order of operations because I have addition and I have division inside the parentheses. So I need to do the division first because that's what PEMDAS tells me to do. So I'm going to rewrite part of my expression here, 60 minus 7, and I'm going to go ahead and keep my parentheses for now. So I'm going to do division first. 6 divided by 2 is 3. I kept everything else the same. Now when you're doing this, you don't necessarily have to write out each piece each time. Hopefully this will just help you understand what I'm doing. So here I was doing all the parentheses. Now I'm going to do the exponent, which is here, 2 to the 4th power. So maybe you already know, but 2 to the 4th power means we have to take 2 times 2 times 2 times 2, which comes out to 16. So there's my exponent step. Now I need to do multiplication, and I have one multiplication. 7 times 8 is 56. There's my multiplication. I don't have any division. I just have addition and subtraction left. So I'm going to work from left to right, meaning I'm going to go this way. So 60 minus 56 is 4. And then 4 plus 16 is 20. And so this was my subtraction step. This was multiplication and division. PEMDAS. We went through it all and we got 20. Okay, so now you have to ask your parents if they know how to do this problem tonight, right? And see if where they're going to probably mess up is they're going to mess up here. They're going to add 5 and 6 first. And then they're going to be like, why would Mrs. Cossack give you this problem with this fraction in it? Anyway, okay. On example 2, so let's evaluate 3x squared minus 5x if x is 4. So I've got to take 3 times 4 squared minus 5 times 4. So I could write a dot here with the 4. I could do parentheses. I use parentheses a lot, to be honest. I like to use the parentheses here because when we see that 2 there, it's only attached to our x. It doesn't belong to the 3. So we want to make sure that I only raise 4 to the second power and not the 3. So if we're going to do parentheses first, I'm going to figure out what 4 squared is, which is 4 times 4, which is 16. And you might be tempted to start skipping steps, and if you feel comfortable with that, you can. Like if you wanted to go ahead and write that 5 times 4 is 20, that would be just fine. So 3 times 6 is 48. There's some multiplication. 5 times 4 is 20. There's more multiplication. 48 minus 20 is 28. All right. On to the next thing. All right, this is the last section, and it's called Expressions from Word Statements. And what the author of the book, Forrester, is trying to do is trying to set up so that you can do word problems. It remains to be seen if this will actually help, but we're going to try it. So, example 1, we're going to try this one. It says subtract 6 from 21 and then add 3. So if you're going to subtract 6 from 21, this is the confusing part, is that you're taking 21 minus 6. So to take 6 away from 21, you want to switch the numbers around and do 21 minus 6 and then add 3. So 21 minus 6 is 15, and 15 plus 3 is 18. Huzzah! Okay, example 2, we have the sum of the squares of x and 3. So the squares of x and 3, that's fairly confusing. I don't know when you're going to see this in a word problem, but let's at least learn what it means to have the squares of x and 3. So that means we have to take x and we square it, and we have to take 3 and we square it. And then we want the sum, so we want to add them together. And you really could just leave it like this for now, but I know that 3 squared is 9. So we could write it like this as well. I'm not even sure in the text which one the author prefers, but they'd both be correct. And that's it. You did it.